We're continuing our lesson on kinematics. Here's another question which says a particle travels in a straight line through a fixed point O. Its distance s meters from a fixed point O is given by s equals t cube minus 9t squared plus 15t plus 40. Where t is the time in seconds. After the motion begins. Calculate distance of P from O when its velocity is instantaneously zero. When the value, find the value of t when the acceleration has a magnitude of 9. Average speed of P during the first 2 seconds. And lastly, total distance traveled in the first 6 seconds. Let me know when you're done noting it down. Okay. A particle travels on a straight line through a fixed point O. Its distance x meters from a fixed point is given by s is equals to t cube minus 9t squared plus 15t plus 40, where t is the time in seconds after the motion begins. Calculate the distance of P from O when its velocity is instantaneously zero. Okay, so you have to find the distance s, but at what time? Because we're not given the time. Instead, we're told that the velocity is instantaneously zero. So let's find the expression for velocity first, equate it to zero, and then get the time from there. So for part A, the velocity is equals to 0. And how do we find velocity from distance? Or displacement, we do ds over dt, which is going to give us 3t square minus 18t plus 15. Equate this to 0. So 3t square minus 18t plus 15 is equals to 0. I'm going to take 3 common and divide it with 0. So t square minus 6t plus 5 is equals to 0. Now do middle term breaking. Multiplication should give 5. Addition should give minus 6. So minus 5t minus t plus 5 is equals to 0. T common, t minus 5, minus 1 common, t minus 5. So we get t minus 5, t minus 1 in brackets equals to 0. So at time is equals to 1 and at time is equals to 5. The object is instantaneously at rest. Okay, so let's find the displacement for both the times. So when time is equals to 1, then S is going to be 1 cube minus 9 1 squared plus 15 times 1 plus 40, which gives us 47. And similarly, when time is equals to 5, you're now going to substitute 5 in place of t in the equation of S and get S equals to 15. Okay. Part 1 is done. Now, what is this telling us? The answer, we might need this concept later, so let's just discuss it right now. So at the start of the experiment, the particle is somewhere at a position O, and that at time is equals to 1, its velocity becomes 0. So let's say it started to move in this direction, and then at time is equals to 1, it is at a distance of 47 meters from the initial starting point O. Now, at time is equals to 1, velocity becomes 0, so now it changes direction. And at time is equals to 5, its velocity again becomes 0. So at time is equals to 5, it's at a displacement of 15 meters from the point O. So it's somewhere over here, 15 meters. This distance is 15 meters, and this distance is 47 meters. So this is what is implied by instantaneous rest. Again, after this, it will change its direction. At t is equals to 1, it started to move in this direction. And then at t is equals to 5, it will start going back in the opposite direction again. Anyway, let's see what the next part is. The value of t when acceleration has a magnitude of 9. Okay. So magnitude means that the acceleration can be plus minus 9 because it says the magnitude is 9. Okay, let's find A now. A is found through dv by dt. And this is V. Derivate this, so we get 6t minus 18. Now, let's find t when A is 9. and when a is -9. This becomes 27 upon 6, which gives 4.5. And when a equals -9, we get which is 1.5. Part B is done. Part C. The average speed of P during the first 2 seconds. So we need the total distance over total time. Okay. Total time we know is 2 seconds. We have to find total distance. Again, let me draw that figure again. We already know that at the object starts to move at a point O, and at time is equals to 1, it had covered a distance of 47 meters. Now, after this, it changes its direction and starts going back. We need the displacement at time is equals to 2. So let's see what that is. So at time is equals to 2, S is going to be, use the initial formula for S given in the question. S is equals to T cube minus 9T square plus 15T plus 40. Substitute 2 here and get displacement equals 42. Displacement is the distance from the point O. It's going to be somewhere over here now. This is time is equals to 2, and this distance is 42. Then the total distance covered by the particle is the initial 47 meters distance plus this distance, which is going to be 47 minus 42, which is 5. So plus 5 meters. So it's going to be 52 meters. And the average speed is going to be 52 over 2. 26 meters per second. Any questions? Okay. Next is total distance traveled in 6 seconds. Okay. So you have to find the displacements at instantaneous rest, because after that the object changes its direction and you have to be careful about how to find distance from displacements. So let's go back to the start. Pehle, the object is at a point O. The first instantaneous rest is at t is equals to 2 and then at t is equals to 5, बल्कि 1 and 5. T is equals to 1 and t is equals to 5. And we had calculated the distances at these times as well, 47 and 15. Displacement, sorry, not distance. So S is equals to 47, S is equals to 15. Okay, so at time is equals to 1, the object is here, and this distance is 47 meters. This is 47, not 14. Okay. Then the object changes its direction. It starts going back. And at time is equals to 5, the displacement is 15. So let's say that 15 is somewhere over here. So then is this is at time is equals to 2, the object is now here. So it initially covered a distance of 47 meters plus, then it came back this way till here. So that is a distance of, what is this, 47 minus 15, which is 32. This is 32 meters. So first it traveled a distance of 47 meters towards the right. Then it covers a distance of 32 meters towards the left. And now let's find the displacement at t is equals to 5. So when t is 5, when t is equals to 2, but I think the distance was something else. 42, sorry. I made a mistake. At अच्छा t 2 पे तो हमें चाहिए ही नहीं. We don't need the distance at 2, we need the distance at 5. So this is 5. ठीक है? And this is t is equals to 1. Let me recap what I've done. I need the distance traveled by this particle from time is equals to 0 till time is equals to 6. Now, I cannot just use the displacement formula at time is equals to 0 and time is equals to 6, because these are the displacements, not the distances. So I'll have to find the displacements for the time when the object is at instantaneous rest, and then see how much distance has been covered within those time spans. So सबसे पहले we know that the object is at instantaneous rest at time is equals to 1 and time is equals to 5. Time is equals to 1 pe, the displacement is 47. So initially the object covered a distance of 47. Then it started to go back. And at time is equals to 5, we know that the distance from the origin is 15. That means कि इस object ने 32 meters का distance cover किया because it's going backwards. Okay, अब फिर object अपनी direction change करेगा and it will start moving forward. और अब हमें चाहिए displacement at time is equals to 6. So again substitute it in the formula and you should get 22. S is equals to 22. So let's say that's somewhere over here. Time is equals to 6 where the distance covered is 22. So यहाँ से लेकर यहाँ तक it's 22 meters. Okay. But between time is equals to 5 to time is equals to 6 उसने इतना distance cover किया. तो पहले ये 15 था और अब ये 22 हो गया. So how much distance has been covered? 22 minus 15. So that's 7 meters. So then the total distance covered is first 47 meters towards the right, then plus 32 meters towards the left, then again 7 meters towards the right, which gives 47 plus 32 plus 7, 86 meters. So the particle has covered a distance of 86 meters between the first 6 seconds. कोई क्वेश्चन है तो प्लीज पूछो. Okay. Then we move on to the next example, which is a particle passes through a fixed point O with a velocity of 7 and moves in a straight line with an acceleration of bracket 13 minus t meters per second square. Where t is the time in seconds after passing O. Calculate the value of t when the velocity is 7 again. Okay, here's the question. Okay, that was part A. Part B is the position of the particle at this instant. A particle passes through a fixed point O with a velocity of 7 meters per second and moves in a straight line with an acceleration of 2 times 13 minus t meters per second square, where t is the time in seconds after passing O. Calculate the value of t when the velocity is 7 again. अच्छा, अब हमें एक्सप्रेशन एक्सेलरेशन का गिवन है, हमसे पूछी वेलोसिटी है. सो वेलोसिटी इक्वल्स इंटीग्रेशन ऑफ एक्सेलरेशन, ये हमें पता है. So that means v is equals to integration of, I'm going to expand the expression, 26 minus 2t dt. Acha. Now let's integrate this. It's going to be 26t minus 2t square upon 2 plus c. Integration कर दी. Just a second. अच्छा, ये मैंने इक्वेशन गलत लिखी हुई है. एक्सेलरेशन इज 2 ब्रैकेट 3 minus t, not 13 minus t. तो फिर ये हो गया 6 minus 2t और ये हो गया 6t minus 2t square upon 2. So we're getting v equals 6t minus t square plus c. अब c की वैल्यू निकालने के लिए मुझे एक वेलोसिटी चाहिए और टाइम चाहिए. ठीक है, स्टार्टिंग में वेलोसिटी बताई हुई है 7 मीटर्स पर सेकेंड है जब ऑब्जेक्ट ओ पे है. तो ओ पे तो टाइम 0 होता है. सो टाइम 0 पे हमें वेलोसिटी बताई गई है 7 है. So let's use this. 7 is equals to 0 minus 0 plus c. So c is just 7. So v equals 6t minus t square plus 7. Okay. Now we need to find t when the velocity is 7 again. So replace v with 7. Find time when v is 7. So we get 7 equals 6t minus t square plus 7. So we're getting 0 equals 6t minus t square. Take t common. So we're getting two answers. For t, one is t is equals to 0. The other one is 6 minus t is equals to 0. So time is equals to 6 seconds. Time is equals to 0 पे हमें already पता है velocity 7. पूछा दोबारा कब velocity 7 होगी, so वो time is equals to 6 पे होगी. This is the answer. Okay. Next part में कहा है find the position of the particle at this instant. So अब हमें x बताना है पार्ट बी में, या s बताना है. फाइंड x और s भी कह देते हैं इसको. at time is equals to 6. Okay. So we already know the expression for velocity. It's 6t minus t square और हमारा c आया था 7. ये c है, not v. c यहाँ 7 आया था. Yes. Okay, so plus 7. 6t minus t square plus 7. Okay, let's integrate this again and get the displacement, because displacement आती है x या s आता है dv upon d, sorry, integrating v से. Okay, let's integrate this. Integrate 6t minus t square plus 7. So we get 6t square upon 2 minus t cube upon 3 plus 7t plus c. अब c निकालना है, तो c के लिए आपको एक t की वैल्यू चाहिए और एक डिस्प्लेसमेंट की वैल्यू चाहिए। तो हमें वैसे ही पता है कि टाइम इज इक्वल्स टू 0 पे ऑब्जेक्ट अपने इनिशियल स्टार्टिंग पॉइंट पे है, ओ पे। सो t इज इक्वल्स टू 0 पे s 0 है, डिस्प्लेसमेंट 0 है। सो यूज दीज पॉइंट्स, तो c भी 0 हो गया। 0 इज इक्वल्स टू 0 माइनस 0 प्लस 0 प्लस c। सो c इज इक्वल्स टू 0। तो s का एक्सप्रेशन आ गया 3t स्क्वायर माइनस टी क्यूब अपॉन 3 प्लस 70। अब फाइंड द पोजीशन ऑफ द पार्टिकल एट दिस इंस्टेंट, सो t इज इक्वल्स टू 6 ले लेंगे और देख लेते हैं कि s क्या आता है। 78 आ जाता है, 78 meters. So this is the displacement at time is equals to 6. कोई सवाल है तो प्लीज पूछो। चलो, that's all from mechanics. Or I'm going to send you a new link to discuss the pure paper. If you've already done it, let me know on WhatsApp and you don't have to join.